All right, so I adapted some notes from last year, and unfortunately I messed the title up. We're not doing notation. So we are doing functions, we're doing intercepts, we're not doing evaluate, we are doing domain and range, okay? So this is what we're doing today. All right, a blank is a relationship between two sets of numbers. Nyla, what'd you get?
Relation.
So a relation is a relationship between two sets of numbers. So if you have two sets of numbers, there will always be this relation, okay? But sometimes the relation is special when every input is paired with one output. Can somebody raise their hand if they know the name for that? When every input is paired with one output? I see one hand, but I'm hoping for a couple others. Might be near the top of the page. Anybody else want to help us? Lua.
Function.
Function, thank you. A relation is a function when every input is matched with one output. All right, so these are examples of functions. Hopefully you look those over. You can have a function represented in a table, in a graph of points, or in a continuous graph. This is called a continuous graph because all of the points are connected. It's not just discrete points. These are not functions down here. Raise your hand if you noticed what made the first one not function. Ian?
Because one x value has two different y values.
Which one is it?
0.
The 0. Did anybody else notice that? So when x equals 0, right, they have two different y values. So 0 is not paired with just one y value. So when x equals 0, there are two different y values. Okay, so that was the problem. All right, what about the graph? In the next graph here, do we have an x that is paired with two different y values? It's hard to tell. When x equals 0, what is the y in this graph? When x equals 0, the y is 2
2
and 4. You see that? So when x equals 0, 0 is in the middle. The y could be 2 or it could be 4. Raise your hand if you remember doing something called the vertical line test before. Anybody remember doing that? Good. Okay. That's what the vertical line test is checking. It's checking to see, is there any x value that has more than one y? Okay? So it's actually the same exact description as before. When x equals 0, there are two different y values. But we can also say the vertical line test. I'd just like you to understand what the vertical line test is doing. And it's checking to see if there is an x value with more than one y value. So I'm going to write all those words out. But I'm also going to write vertical line test. Notice I'm writing the exact same thing. Okay, so when x equals 0, there are two different y values. I'm also going to write vertical line test. Okay? And then the third one, it's also not a function. It says it right here. These are not functions, right? It's not a function, and you can see how it would fail that vertical line test. And actually, you could put your line like almost anywhere. The only place I wouldn't put my line is right here at the tip of this sideways parabola. But you can see if you put it here, you get two different values. If you put it here, 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 it fails the vertical line test a lot of different times. But I'll use this one as an example. When x equals 1, there. Good morning. Can you lock the door? Are two different. Thank you. y values. And I'm also going to write vertical line test. Okay. So if it's a graph, you may just write vertical line test, and that's okay. All right, for your reason. However, if you write the other reason out, that is also acceptable. So I want you to take a minute and put yes or no for these four, and then I want you to answer why or why not. All right, first one, function or no? Yes or no? I heard no. Anybody want to agree with no? All right, let's take a look. 0, only 1 0. 1, oh, there was a problem, right? So that was a no, because when x equals 1, there are 2 y's. Questions on that one? All right, next one, yes or no? No, very good. Now, you could have chosen a value like when x equals -1, there are 2 y's. You could write that out. Or you can simply write vertical line test. All right, next one is a set of points. We haven't seen one like this before. I'm going to have you guys share your answer with me this way. You're going to either give me a thumbs up for function or a thumbs down for not function. Everybody share your answer. Thumbs up or thumbs down? I'm still waiting on a few. Okay, excellent, good. It is a function because I checked all my x's, right, and they don't repeat. So since I don't have an x with different y's, it is a function. Every x has 1 y. Okay, and the last one, yes or no? Yes, good. It passes the vertical line test. When I draw my vertical line, it only crosses the graph 1 time, right there. Okay, take a moment to make sure that page is perfect, and then you can turn the page. Sorry. The x-intercept is where we cross the x-axis, and the y-intercept is where we cross the y-axis. Sometimes you will have multiple x-intercepts, but if it's a function, you won't have multiple y-intercepts. If it's not a function, you could. So looking at this, I want you to write the points where we cross the x-axis for x-intercepts, and the points where we cross the y-axis for y-intercepts. So for the x-intercepts, this one back here is at -2, and then this one up here is at 7. So I have -2 and 7, and the point would be -2 comma what? 0, good. -2, 0, because the y value there is 0, and also 7, 0.
Wait, where's 7?
So over here, yeah. Okay, for the y-intercept, it's up here. The y value of the y-intercept is 4. And what is the x value? 0, good. Okay. Take a moment to look at these parent functions that are on this page. And leave that there so people can see that still. Take a look at them, and I want you to put a little check next to the ones that you've worked with before. All right, so linear, quadratic, exponential. Raise your hand if you checked all 3 of those. Excellent, because we did those last unit, right? We did linear, quadratic, exponential. Next row. Did anybody check any of these? Absolute value, square root, logarithmic. Did anybody check any of them? A couple of you did? Okay, we haven't done them in this course, but maybe you did them in a different course, right? And then at the bottom, raise your hand if you checked any of these. Rational, cube, or cube root. Anybody do those? Okay. So some of you have some extra background knowledge. That's good. The ones that we've talked about so far are these 3. We're going to learn these also. These graphs are not 100% complete. So they're missing some things. One thing that they're missing is some arrows at the ends, but don't get ahead of yourself here because there's at least one point that's not an arrow. So we know that the line will continue forever. The parabola will continue forever. And so will the exponential. And we started to talk about this a little bit, but an exponential function has something that's important that you want to include in any graph of an exponential function, which is an asymptote. An asymptote is this invisible line, and for an exponential function, it will be a horizontal line, and the function will never cross that. So the parent function has an asymptote at y equals 0. It's right on the x-axis. So draw that dashed line, please.
How do you spell that?
Right on the x-axis. And here's the word, asymptote. Has a silent P, just to make things difficult. Asymptote. Okay? So exponential has a horizontal asymptote, and I put arrows on all three of those in the first row.
Should we write horizontal?
Sure.
It's quadratic or exponential is always horizontal.
Yeah, that would be a good thing to note on your paper. All right, absolute value has two arrows, but be careful on the square root. The square root has one end point and one arrow. Logarithm is interesting, first of all, because there's like a whole word in your equation there, right? Logarithm is also interesting because it is the inverse of the exponential function. So think about that word inverse. What's the inverse of multiply? I heard one answer. Divide. Good, yeah. The inverse of multiply is divide. The inverse of adding is subtract, right? The inverse of exponential is logarithmic. They undo each other, okay? Whereas the exponential has a horizontal asymptote, the logarithmic has a vertical asymptote at x equals 0. So logarithmic will always have a vertical asymptote. You can transform it so that the asymptote moves around, but it always will have one. And then the rational function has two asymptotes. So the rational function is going to have, oh, I never put the arrows on the logarithm. So the logarithm does have arrows on both ends. The rational function has two asymptotes. It's going to have a horizontal asymptote and a vertical asymptote. And when we study rational functions in depth much later in the year, you're going to find some more interesting things about those asymptotes. It can have more than one vertical asymptote, all kinds of fun things. All right, cube function, x cubed, put some arrows on it, and cube root, put some arrows on it. And interestingly, just like squaring and square root are inverses, cubing and cube root are inverses of each other. They undo each other. All right, so one thing you're going to need to be able to do is be familiar with these shapes.
Wait, what's the inverse of cube?
Cube root. So make yourself a note to study these shapes. Okay? If you draw them on flashcards, then you could put the names on the back. You do need to know these shapes. I just added the arrows to the rational. Sure you're on the correct side. Blank is the set of all x values, blank is the set of all y values, or f of x values. Remember, f of x is just a fancy way to say y. Domain, is that x or y? It's x, very good. So domain is the x values, and range is the y values. If you were here for SS very early in the year, we started talking about domain and range in SS, and then now we're gonna really make sure we got it. I want you to look at the examples here and see if you can answer the questions below using those examples. All right, so remember, domain is your x values. You read your x values from left to right. So this graph starts at -2. You see -2 is your first x value. And then it goes over to 4, left to right, -2 to 4. This is interval notation. And this one is sometimes called set and sometimes called inequality notation. Okay? So set / inequality notation. It's two different ways to write the same thing. On a test or a quiz, unless it says the notation you have to use, you can usually choose what you want. However, we will communicate with you. Algebra 2 teachers will be communicating with you mostly in interval notation. You do also need to understand the inequality notation in case it shows up on like an SAT or something like that. Okay, so you need to know both. Does anybody have a question about the domain before I go over the range? Okay. Your range is the y values. You read your y values from the bottom to the top. So on the very bottom, my smallest y value is -3. And then when I go to the top, my largest y value is 0. So remember, we're just looking at the y's right now. Oops. Smallest y value is -3. Go to the top. My biggest y value is 0. What questions do you have on that? Next one, domain. So your domain is 2 to infinity. So starting here at 2 and then going to infinity. These arrows keep going all the way to the right, which is taking you to infinity in the x direction. You can also write x is greater than or equal to 2. So starting at 2, all the numbers greater than or equal to 2 are in the domain. Here's your range. This arrow is not only pointing to the right, it's also going down. And at the very bottom, we have -infinity. This arrow is going right, but it's also going up. And at the very top, we have +infinity. Okay, so we have -infinity to +infinity for your range. You can also say y is an element of all real numbers. And here's a shorter way to write all real numbers. Y is an element of all real numbers. You see how the R has an extra line on it? The R with an extra line means all real numbers. Does anybody have a question on that? Okay. Which symbols mean that an interval includes an endpoint? So some of you noticed that we include the endpoint with a square bracket, like that. And then also in inequality notation, it would look like this. If we don't include an endpoint, we're going to use a parentheses. Or we'll use a less than that does not have an equal on it. All right, and if you have an arrow at the end, then it's going to be going to what? Infinity, good. Or it might be going to -infinity. All right. There's a word bank here for the domain and range, but not for the intercepts, because I think the intercepts are a little bit easier. Okay? Let's do one together. Let's do the intercepts first. Remember, there's no word bank for intercepts. So I need to find x-intercepts and y-intercepts. Okay, where does my graph cross the x-axis? What number? 3, good. So I'm going to make the point 3, 0. Where does my graph cross the y-axis? -1, right? And -1 this time is the y value, so that goes there. 0, -1. So I was talking about this point and this point, okay? Intercepts are points. They look just like intervals because they have parentheses on them, but they're not. All right, so intercepts are points. These will be both intervals. We're going to write the answer as intervals and as inequalities. Okay? I want you to notice that this domain has a point here and an arrow here. So my domain starts at what number? What's your first x number here, guys? -1. And it goes until, it goes to the 5, but there's an arrow, so it keeps going, right? All the way to what? Infinity. So looking at my answer choices, should I use the first one or the second one? What do you guys think? First one or second one? Talk to your neighbors, guys. First one or second one? All right, guys, square bracket, right? Because we want to include what number? -1, good. Okay. Look down here at the domains in set notation. I know it's going to either be the third one or the fourth one. Talk to your neighbors. Is it the third one or the fourth one? When we finish this. All right, can x equal -1? It's filled in, right? Since it's filled in, x can equal -1. So it's going to be greater than or equal to -1. If it was an empty dot, then that would be a no.
Wait, if it's empty, is it just greater than or less than?
Just, yeah, so that would not have an equal if it were an empty dot.
No, but then if it's an empty dot, it's not or equal.
Right. All right, range. Your range starts at the bottom at your lowest y value. What is that lowest y value? It's -2, see down here? So it starts at -2, and then it keeps going up to what? That arrow keeps going to what, guys? Infinity. All right, let's look at our choices. Oh, it looks like it's going to have that square bracket on it to include the endpoint. And then this time you use y, because we're talking about the range, and those are y values. Greater than or equal to -2. Now, do not cross those off because it says may be used more than once. So don't cross them off your word bank, okay? I want you to spend a few minutes doing this before we go over it. Work together with your partners. Talk to them and see if you're getting the same thing. Use the word. All right. In this one, for the domain, this arrow goes all the way to the left to -infinity. This arrow goes all the way to the right to +infinity. So one wrong answer I have seen on a lot of papers is -infinity to infinity. And the reason why it's wrong is because you are forgetting that you have to leave out one number. Let me see if I can zoom this for you. Okay, look. It starts at -infinity, and then it goes all the way to -1. But do you see that dashed line? That dashed line means that we are not going to hit that dashed line. We're just like that line, this here, it kind of plummets and it never hits the dashed line. On this side also, it never hits the dashed line. The dashed line, of course, is called the. So we want negative infinity to infinity, except we need to leave out negative 1. And this is how we do it. Up here. Oops, almost. This one. It's negative infinity to negative 1. This U means union, but it basically means and. Okay, so negative infinity to negative 1 and negative 1 to infinity. But notice those parentheses mean leave out the negative 1. So not including negative 1. This is how you say every number except for negative 1. Okay? So I'm going to copy that from my word bank. My domain is negative infinity to negative 1 and negative 1 to infinity. Every number except for negative 1. So now if you look in the row below it, you should be able to find the inequality notation too. It is x is an element of all real numbers except not negative 1. Okay? So remember, this R means all real numbers. It's my short way of writing all real numbers. So every number except negative 1. You should have that on your paper now. We're on the last page. All right.
What does it say after the R?
It says comma, x does not equal negative 1. The y is similar. What number can the y not be? Look at your y's, read it from the bottom to the top. What number can y not be? Okay, anybody agree with 0? Yeah. We have to leave out the 0 because we have a horizontal asymptote at y equals 0. So it's not gonna cross that line there. So every y number except for 0. So it's gonna look similar. It's gonna be negative infinity to 0 and 0 to infinity. And then writing it in interval notation. Okay. So the y-intercept was 0, 1. The x-intercept was none. All right. I am going to give you 5 minutes to see what else you can do here. If you are really, really stuck, follow the advice of some of your neighbors and do the intercepts first, because those are just points. Then you can try the domain and range. I think we did the hardest one already. I think the rational was the hardest. Oh, we didn't write the type. This is rational. What was the one above it? What was this one, guys, with one endpoint and one arrow? Did you look back in your notes? What's it called? Yeah, I heard one person say it. Yes, thank you. It is square root. Okay, so square root, then rational. All right, work please on those last 3. I'm giving you 5 minutes to do that. All right, guys, first, type. What type is this? It makes a U shape, which is a parabola, and it's called what? Quadratic. Excellent. You should be experts on that by now. All right, quadratic. This arrow goes all the way to the left, which is negative infinity, and this one goes to the right, which is positive infinity. So for your domain, you should have negative infinity to infinity. The way you write that in set notation is x is an element of all real numbers. You can write the words all real numbers out, or you can make the... All right, for the range does have a lowest point. It's right here. And if you look over here, you can see that the range starts at the number 2. And then these arrows go up to infinity.
The R means all real numbers?
It does, yeah. So for your range, I'm going to look at my answer choices, and I found this one. Square bracket to include the 2. You always put a parentheses on the infinity. because you can go towards infinity, but you can never get there. That's a kind of deep thought for a math class, right? You can head towards infinity, but you'll never get there. All right. Then we're looking for how to write this in inequality notation. And I found it up here. Right here. Y is greater than or equal to 2. All right, this function does not have what type of intercept? It doesn't have an x-intercept, right? See how it doesn't go low enough to have an x-intercept? So no x-intercept. And then what's the y-intercept going to be? 0, comma what? Oh, I didn't label that. So 0, 6 is my y-intercept. Okay. The next one has a vertical asymptote. If it has a vertical asymptote, is it exponential or logarithmic? It's logarithmic. Very good. So it's a logarithm.
Wait, what makes it that from exponential?
The asymptote. If the asymptote is vertical, it's a logarithm. Okay. Your domain starts right after -1. Remember, it can't include -1 because there's an asymptote there. And then it continues to the right, which means it goes to what? Infinity, thank you. All right, so all the numbers from 1 to infinity, not including 1. So that's going to be the same as x is greater than what number? -1, right? X is greater than -1. Those are all the numbers that are bigger than -1. Question? Okay. This arrow goes all the way down to -infinity. This one, even though it's going to the right, it's also slightly going up. And so even though it's moving very slightly up, eventually it's going to head towards positive infinity on the top. So because it has an arrow, it does not stop. So your range is -infinity to infinity. -infinity to infinity is all real numbers. Remember to use a y here. Y is an element of all real numbers. Oh, and we have both types of intercepts. X-intercept and y-intercept. Okay, x-intercept is what, comma 0? That's right. Good. Your x-intercept is right here at 3, 0. Your y-intercept is at 0, comma. Okay. Sorry. Those were your intercepts. We're doing the last one. Looking at the shape of this one, comparing it to the shapes of the parent graphs. If you haven't done it yet, do it now. Compare it to the shapes of the parent graphs. What do we have here? Cube, right. It's a cube function. Sometimes you write it as this. Sometimes you would write cubic. It doesn't matter. Cube or cubic. Okay? Anybody think you have the domain? Starts on the left with an arrow. It ends on the right with an arrow. So it's going to be -infinity to what? Infinity. Good. So this arrow is going left and it's going down. This arrow is going right and it's going up. So both your domain and range are -infinity to infinity, which is the same as all real numbers. Your x-intercept